My name is Matt Devoti, and my language was Mozart Oz. So, just a history about it. It was originally developed by a man named Gert Smolka and his students, who studied at University Catholique de Louvain in Sweden. Later on, two men named Saif Haridi and Peter van Roy joined in 1996. They were from the Swedish Institute of Computer Science, and they added a lot to the language's development as well. The Mozart Consortium took over development in 1999. They brought the most to the language. The Mozart Consortium consisted of University Catholique de Louvain, the Swedish Institute of Computer Science, which were the universities of the first two groups who developed it, and then also a third university called the Saarland University. So those three made up the Mozart Consortium. In 2005, a specific group of the Mozart Consortium was developed called the Mozart Board, and they had the goal of developing the language and trying to spread it to make it more accessible to a lot more people. The original goal of the language was to be used as an educational tool, which will make sense later on how that was done. But also now it's used for various other purposes, such as use in the business world and use in private development and all that. So one of the biggest or best known aspects of this language is that it's a multi-paradigm language. It can be used in a lot of different ways. A multi-paradigm language acknowledges the fact that not any one paradigm is going to be the right one for every situation. So what it does is it allows users to use various different paradigms together within the same language without having to switch between languages or different setups or anything. It can all be done in one language in one setting, and it allows users to work on things in the most efficient way possible by going to whichever paradigm will allow them to work efficiently. So, a couple examples of paradigms include object-oriented. That's a very common one used in Java and C. There's declarative and imperative programming. There's a lot more too, but those are just a few. So, here's an example of one paradigm specifically, which is being used as an AI program. I found this interesting. The point of it is to build this bridge, and it tries to figure out which, where it should put the posts, where it should dig it out places, and it figures out on its own where to build the bridge. It wasn't told how to do it, just what the final product was, or what they wanted the final product to be, and this is what they did along the way. And the program figures out how to build this bridge, and it's kind of a simulation of that. Oz also is good for GUI programs, as is evidenced here. So it's good for visual sorts of programs. So another thing that is a well-known feature of Oz is that it has a lot of syntax sugar. Now, syntax sugar, all that is just an addition to the syntax of a language that does not alter the functionality but increases readability. In other words, it's sort of a lot more ways to code the same thing. It gives the user, the developer, a lot more different options to code the same thing. In the example down here, all four of those lines are obviously of different syntax, but they're all valid in Oz and accomplishing the same exact thing, which is making a list that consists of the values 2, 4, 6, and 8. So syntax sugar basically just gives the user a lot more options. This syntax sugar, along with the multi-paradigm aspect of it, both play a huge role in Oz's original purpose of being an educational sort of program. They give the user a lot of different sort of exposure to different paradigms, and also in this case syntax sugar, because other languages might have one syntax for making a list, for example, but because Oz has multiple, they'll get exposure to if not the exact syntax of another language, similar syntax, and different versions of that syntax that they might find in different languages. Obviously, the syntax trigger isn't limited to lists. It exists in a lot of aspects of the program. It can be found in a lot of different sorts of functions. There are multiple options in a lot of different syntaxes. Another very good aspect of Oz's concurrency. A lot of people say it has very good concurrency who use it. All the concurrency is just a system's ability to allow multiple computations to run simultaneously. So instead of just running one linear execution, there are multiple things going on at the same time in the same program. Now, the two biggest problems that a lot of programs run into with concurrency are deadlock and starvation. Now, Oz is known as being a programming language that handles concurrency very well, so compared to other languages, it's less likely to run into these. They become more common when there are more paths open. So this is an example of concurrency. So a normal program, let's say, has multiple functions to be run. That's displayed up top in a way with the two lines of people and the one Coke machine. They all have to go one at a time to the Coke machine. But below there are the two queues and the two vending machines. So both queues can move along to the vending machine at the same time. Now, for example, in this scenario, a deadlock would be where, say, the two people at the front of the line are friends and they both only have $20 bills and the machine takes a 1 and a 5. Now, they're both going to wait for the other one to buy their Coke and ask for change, but they're not communicating with each other, so they are just stuck waiting for the other person's change without either one making any move. That's basically what happens in deadlock. There are two processes or functions or whatever it may be that are waiting for information from the other one in order to complete, and because neither one is getting the information, the program kind of gets stuck in that position. Starvation would be, I guess, the best example using this scenario of the Coke machines would be where, say, a Coke machine runs out of an option like Coke or whatever it may be, and the line is held up then because the person wants that specific drink. In starvation, for because of an error or any number of things, um, because it's run out of Coke or because of an error or any number of other things that could happen that would prevent information from coming through, the Coke machine is, or the, because of an error or something in the computation, and a function or something of that nature is waiting for information that it's not getting, and the program gets hung up on that. Another good aspect of Oz is that it has lazy and eager evaluations. Lazy evaluations are only run a computation when that result that the computation would produce is needed. They're designated by the addition of lazy in a function declaration. Eager evaluations are the default and run computations regardless. This is what a lot of programs such as Java will use. So examples of the syntax: eager just has fun, which stands for function, followed by the parameters, and then whatever logic follows that. Lazy has fun, followed by the word lazy, and then the parameters, and then whatever logic would follow that. So here's a brief snippet of code, and what this code does is it's possible for this computation to run an infinite amount of times, or if not infinite, a lot of times, depending on the situation. Now, that would obviously slow the program down a lot if it were done in eager evaluation. So by adding lazy, what this does is it prevents it from doing any unnecessary computations and only runs this if the result that it would produce is needed later on. So one last aspect is function versus procedure aspect of this. Uh, they're very similar, but they're slightly different. The function on the left is sort of, I guess, the syntax you would expect for a method or a function, where it just has the function and then the parameters, the logic, and then the end. Now, procedure is slightly different. It has the proc for procedure. The parameters, now after the parameters is the letter B, that's a variable that is being created, and the logic is being set equal to B, and then the procedure is ended. So they're very similar, they accomplish the same thing, but they're slightly different. The, that's another example of syntax sugar in Oz, just the fact that those two are different. And because they're similar, it doesn't really make a huge difference which one is used, but the general rule for these is when nesting procedures or functions, you only do procedures and procedures and only functions and functions to keep it consistent instead of nesting them in each other, which kind of confuses things and makes the readability a bit worse. So, in conclusion, I think Oz has grown a lot since its inception. It's got a considerable size. It's known for having for being a very big program with a lot to offer within it. Um, it's very useful because of its multi-paradigm approach and syntax sugar.
Connect to the internet.
It's very useful because of its syntax sugar and multi-paradigm approach. It's useful for programs that need concurrency because it runs them very well. It's useful as an educational tool and was originally as it was originally intended to be used, and it's useful in the real world as well for those same reasons, for it being very multifaceted and having a lot of options. So these are my sources. They're kind of listed strangely, but the same exact sources are listed in my essay in a much better format. So that's that.